Okay, we're going to see if this series converges or not, and of course it's a good idea to put this into the sigma notation first. And let's go ahead and do that. So here we go. The sum as n goes from 1 to infinity. Notice that on the top we have 1, 4, 9, 16, 25, 36, and so on, so on, so on. Name the n square. So that's it. And then on the bottom, notice everybody has a square root. So let's go ahead and open that square root. And if you look at the inside here, this is 2, and then 9, and then 28. 28 is like 27, huh? It's like 27 plus 1. 64 plus 1 is 65. And 125 plus 1 is 126. And if we look back, 1 plus 1 is 2. 8 plus 1 is 9. Yes, it's the perfect cube plus 1. So here we have n to the third power plus 1, like this. Okay, based on this, how can we see if this series converges or not? Well, if you imagine to do some integrals right here, can we integrate this right here? Sure, you can actually integrate this. If you would like, you can use integral test. But to use the integral test, be sure you graph the function x squared over square root of x cubed plus 1, and you'll realize that that function does not even approach 0. The truth right here is that we can just do the following. Again, this is a series that we're trying to do, but let me just go ahead and check the following. I'm just going to check the limit as n goes to infinity. Yes, we are doing the test for divergence. And you'll see just this part, which is the n squared right here, over square root of n to the third power plus 1. And of course, this right here is just a power situation. You can look at this and look at that. The 1 doesn't really matter. So this is the same as the limit as n goes to infinity. On the top is n squared. On the bottom, this is n cubed in the square root. The square root is the same, 1/2 power. 1/2 times 3, that's a new power, namely 3/2. Simplify the powers, you will know that this right here, this is gone, and 2 minus that, right, which is just 1/2 on the top. And then we have the limit as n goes to infinity of n to the 1/2 power. Put infinity to here, to the 1/2 power. This right here will be infinity. Well, infinity is of course not equal to 0. Therefore, this right here, what's the conclusion? Yeah, this right here diverges. And what's the reason for that? Well, we did a limit check right here, right? So, diverges by test for divergence. All right? So, don't just like use the integrals without doing check on that. This right here, you can just do a test for divergence. That's it. But if you did the integral, you will end up with divergent. But the problem is that you technically cannot use the integral test because it's what? Positive, but this right here actually is increasing. So that's not good. Anyway, this right here is it.